This on the marking scheme, okay? What's the human female cell called? Well, it's called the egg. What is the male sex cell called? Sperm. Next one. Where is the female reproductive? Where in the female reproductive system is the female sex cell produced? Well, that would be the ovaries. Now we can see the marking scheme here. So, and then, sorry, the first answer actually doesn't give us the answers for the first one, so I gotta do this on my own. In the diagram, draw a box around the male cell in fertilizing. So draw a box around the sperm. Okay, and then state one way of reducing the chance of sexual intercourse could result in fertilization. Well, you could use condoms, or you could have sex outside the fertile period. So we can say it's condoms or sex outside the fertile period. Okay, sorry, that's maths. Condoms or sex outside the fertile period. Okay, let's continue on this, and let's get, oh dear, where is my, there they are. Now, let's keep going. Okay, the diagram shows the reproductive system. Name the parts labeled X and Y, and then we'll look at some of the other parts now. Let's do this. Okay, so X and Y would be the testes. Y would be the sperm duct, which carries the sperm from the testes to the urethra. Sperm duct. Name the male gamete producing X is sperm. And then name tube Z, that is part of the male reproductive system and part of the urinary system. I think Z is the urethra, but we'll definitely check our answer. So let's go to my marking scheme. Urethra is the correct answer. Okay, let's move on to the next question. So the next question after this is shows you the line of the uterus and what happens to it during the menstrual cycle, and we gotta answer some questions on these parts. Okay, so let's give it a look. Okay, so what begins on day one of the menstrual cycle? Well, I believe that's menstruation, where the uterus breaks down. You can see the lining is quite thick, and then it drops to this thickness here. So I'd say menstruation for the first one. Okay, so menstruation, menstruation. So let's have a quick look at the answers here. First answer is menstruation, breakdown, shed into uterus. Okay, now we're on to part two, where pregnancy can occur, or where fertilization is most likely to occur. Where pregnancy is most likely to occur. Oh, sorry, when pregnancy is most likely to occur. It's just a period in time. Okay. What happens to the female gamete egg during fertilization? I think what happens is the sperm fuses with it to become a zygote. Sperm fuses to the egg to become a zygote. Okay, let's see what the marking scheme have to say about that one. Oh, sorry, this is the marking scheme. Fuses with sperm to form a zygote. Alright, that's grand. Okay, let's keep continuing here. Let's go further down. Okay, we had more questions. Label the part F where fertilization usually occurs, and label the part with P where the fetus usually develops. Okay, so fertilization usually occurs in the fallopian tubes, which be F, and the fetus usually develops in the womb, which is P. Okay, guys, happy enough with that? All right. Let's move to the next question. The diagram shows the 28 cells of the human female menstrual cycle. What is meant by the fertile period of the menstrual cycle? Well, we already answered that a minute ago. It's when the female is most likely to get pregnant. So when the female is most likely to become pregnant. Okay, and describe what range of days between 1 and 28 menstruation most likely occurs. Menstruation is days 1 to 5 usually. So days 1 to 5. Once again, guys, always check your answers. So days 1 to 5. Okay, now we're on to question 5. Okay, so we got more reproductive questions. Okay. Mark A where the fertilization most commonly occurs. So A would be here somewhere. Mark B where the place where the successful implantation of the zygote occurs. Well, usually occurs inside the womb. So around B here. Okay. Explain how one named form of contraception prevents conception. We'll just go for the condom. And what happens is it prevents sperm entering the vagina. Okay, very easy one. Any other acceptable answer will be good with that. Okay, and we're going to move on to the next question. Next question after that is question 6, the male reproductive system. And we just got to give the functions or the roles of certain parts of this system, okay? So, let's find out. Now, role of A. A is a sperm duct and it's used to carry sperm from the testes. From the testes, okay? I might actually just grab the marking scheme on this one. Good to be exact. So, here's the marking scheme on this one. And we'll do it onto the same page, okay? So, let's have a look at the role of A. A transports sperm or carries, sorry, what did I say there? Transfer sperm from the testes. Okay, B. Releases sperm in sexual intercourses. So the penis releases sperm in the sexual intercourse. Okay, C. Produces sperm because it's the testes. C is the testes, so it produces sperm. Okay. The sperm has a head and tail. State the role of which. The head contains DNA. And penetrates the egg. And the tail is used for movement of the sperm. Essentially like a fish, like. Okay. Next question after that. All right, what is contraception? We can do this quite quickly. Contraception is the prevention of pregnancy, okay? It's the prevention of getting pregnant. Prevention of pregnancy. On purpose, okay? Given them form contraception, the condom, okay? Very easy, let's move on. Okay, so we got the stages of pregnancy, okay, and we're going to go for two functions of the placenta, which would be the next thing we're doing. Give two functions of the placenta, okay, so sometimes, once again, it's good to have a look at what we're doing here. So you can do anything from this list here. So we'll give you a full list on this one. Okay, the placenta does food passes from the mother to the baby. The placenta passes oxygen from the mother to the baby. It takes waste from the baby out of the mother as well. So it takes waste from the baby into the mother's system, and then the mother removes the waste from her body. Okay, antibodies pass from mother to baby. Mother produces hormones for the baby, and then water passes from mother to baby. So any of those roles will be good for the placenta. Okay, any of them. Okay. Now, question 3. What's the function of the umbilical cord which connects the baby to the placenta? Well, the umbilical cord carries blood to the baby, and what's inside the blood would be food and oxygen. So we imagine it'd be some sort of answer like that. Carries nutrients and name nutrients to baby, carries waste from baby. Okay, so they don't want to necessarily talk about the blood. They're talking about, if we re-look at the question again, what's the function? Okay, so it says carries nutrients, or you can say carries food or oxygen to the baby, and carries carbon dioxide and salts away from the baby. Okay, so that is your answer for the umbilical cord. Okie dokie, let's keep going. Descriptively describe 4 events that occur at the end of pregnancy, just before birth, and all the rest. Okay, so we're describing the parts of pregnancy. Okay, so here we are. And what I'm going to do once again is just going to grab it from the marking scheme. Okay, and here it is here. So we'll have a look at this part here. This is usually worth 12 marks, this type of question. Okay, and we'll lob it in here. Okay, so what can happen is any 4 from the following. Uterus contracts, baby is moved to the cervix opens, amniotic sac breaks, baby is pushed out, umbilical cord is tied and cut, the afterbirth where the placenta and umbilical cord come out, the breasts start producing milk, the breasts contain food and antibiotics, bonding between mother and baby. Any 4 from anything on this list. Okay, and you're good to go. All right, let's look at the next question. All right, we're on to forces now. Okay, so we're doing all right. So we got this question here. So on to a new page, okay. A spring was suspended, equal weights were added one at a time. The extension of the spring was noted each time. When the first weight was added, the extension was 2 centimeters. What was the total extension when the second weight was added? Okay. It's an interesting one. First weight was added, section 2. Second weight was added. I think it should be 4 centimeters, because if one weight does 2 centimeters, then 2 weights should do 4 centimeters. Explain your answer. Extension is proportional to the force applied to it. Applied to it. Okay. So if one weight causes 2 centimeter extension, 2 weights should cause 4 meters extension. Or sorry, 4 centimeters extension. Okay. Let's find out what the marking scheme had to say for itself. 4 centimeters. Extension is proportional to the weight added. I like my answer. My answer had a bit more detail, but we'll work with that. Okay, let's get on to the next question. The force of friction exists between tires of a car and surface of the road. How can this be useful for drivers? Okay, well, it's useful for drivers as it keeps the car gripped to the road. So, how can this be useful for driver? Enables cars to grip the ground, and move. Explain how friction affects the tires. The tires lose rubber. Lose rubber over time. And provide less grip. So there's wear and tear on the tires, okay? Alright, go to the next question. So that's 10 done, now we're on to question 11. Okay, we'll go for Hooke's law. And then we'll go for the question with the graph on it. And we'll see how we're doing. Okay. Let's give it a second. Okay, so Hooke's law is extension is directly proportional to the force applied. It's directly proportional to the force applied. Okay, the student was given a box of identical springs and asked to analyze them so that they could be used as Newton meters. The student performed an experiment using an apparatus shown diagram on one of the springs. In the experiment, the student measured the increase in length of the spring caused by the number of weights. The spring was tested to destruction. Weights were added until the spring was damaged. The data from the experiment is given in the table. So we have this table here, and we're probably asked to draw a diagram, so I'm going to have to make this a wee bit smaller so that it fits in. I think we're nearly there now. There we go, much better. Okay, so what we're going to do is weight on this axis. So weights go up in 0.4, so we can say that's 0.4. This is 0.8. This is 1.2. This is 1.6. This is 2, and this is 2.4. Then extension, I'll go up in try and go up in twos. So 2, 4, 6, 8, and 10. Now guys, please remember that there's in between 8 and 9, let's say for example there's 5 boxes, so each box will be worth 1. So 1 above 8 is 8.2, 2 above 8 is 8.4, etc. Okay, so we're going to draw this graph here. So we're going to start off with 0, 0, which is the blue dot. Then we're going for 0.42, 0.84, 1.26 more than likely, 1.68. Now it starts to break the trend. 2 is 8.5, which is around here, halfway between 8 and 9. And then 2.4 is 8.6, which is 3 blocks above it. So at the beginning it obeys a straight line, like so. And then at the very end, however, it starts to bend. So you have to draw it like this at the end, like that. Okay. Now, next graph. Use the graph to find the weight that would produce a 5 centimeter extension. Well, 5 centimeters is in between 4 and 6. So we're going to do this technique here. We go to 5, go straight down, and then halfway in between 0.8 and 1.2, which would be a weight of 1 Newton. Study your graph carefully. The spring obeys Hooke's laws for the earlier extensions, and then when the spring becomes damaged, it does not appear to do so. Estimate from your graph the weight after the addition of which the law no longer applies. I think it no longer applies after down here 1.6 newtons. So I'd say after 1.6 newtons. Okay. Alright, Now, we're moving on. Okay, distinguish between the difference between mass and weight. Well, one thing is weight's measured in newtons, mass is measured in kilograms. You could say is mass is the amount of matter in an object. Weight is the force of gravity acting on that object. Okay, happy days. Okay, let's continue a bit longer. Okay, so we have another extension question where we're going to add weights onto a pan, and then when we add the weights onto the pan, the spring will stretch, and then we have to draw a graph of said spring in this diagram here. Okay, and then we're going to have to answer some questions about this diagram. Okay, happy days. So first things first, a pupil used apparatus shown in diagram to investigate the relationship between the force applied and extension produced in a spring. Pointer P was used to read the scale, weights were added to the pan, and applied forces so to spring. Did that record in the table below? Okay, so that's great. So essentially what you're doing is you keep adding on weights and the spring gets larger, so you get a weight like so. Like let's say this is a weight and this one over here is a weight. You put the first weight on, spring gets longer, put the second weight on, spring gets longer. So we're going to have to fill out this table first and foremost, and then we're going to have to draw out our graph, the usual. Okay, so scale reading 31. Now where does it starts off 31 start, then it's 4 centimeters bigger. 35 take away 31, 39 take away 31 is 8, 43 take away 31 is 12, 47 take away 31 is 16, and finally 51 take away 31 is 20. So we have to point 0, 0, 2, 4, 4, 8, 6, 12, 8, 16, and what's it, 10, 20. Okay, cheap way of doing this is it's a straight line, so you can do the first point and the last point, which is 10, 20, a force of 10, an extension of 20, and then you know your line goes up like this, like so, and then you know every second point, 2, 4. Is that right? Yeah, 2, 4, 4, 8, 6, 12, and 8, 16. There you go, there's your diagram there. Okay, let's move on to the questions which are following this, no doubt. Here we are. So, what conclusion can be drawn from the graph regarding the relationship between force applied and the extension of the spring produced? Okay, well, what we can say is that force applied is directly proportional to the extension of the spring. Okay. Use the graph to determine the weight of a stone that produced an extension of 14 centimeters on the spring. So we go back to our graph, we go up to 14 centimeters, which is here. And we use our graph, so we have to draw a line up from 14 and across And what we get here is 7. It should be 7 centimeters, guys. If I made a mistake, it's definitely 7. So in between 6 and 8, which is 7 newtons, we'll do that. Okay, so that is 7 newtons. Okay, next question. When surfaces make contact with another surface, friction forces arises. Friction makes movement more difficult. Sometimes friction is useful, other times it's unhelpful. Give one example of when friction can be useful. Okay, so friction can be useful for tires gripping the road. Give an example where frictions can be helpful: when brakes wear down or when tires wear out. When brakes wear out, anything like that. How can friction be reduced? By lubricating surfaces. Example, using oil in a car or oil on a bike. Sorry, on a bike. How can friction between air and a moving vehicle be reduced? Air streaming or aerodynamics is where you design the cars to be more aerodynamically efficient. Be interesting to see what the marking scheme said about that one. Let's find out. I think we're all the way at the end now. I think we did a good few of these. Smooth surface, shape of vehicle. So here's the answer they gave for that. How can it be reduced? So we'll have a look here. Streamlining smooth surfaces, shape of vehicle, spoilers, attachments create smooth airflow, anything aerodynamics. Yep, you name it, it's there. Okay. Now, next one. I think we're close to the end now. And we're done. Okay, it took me 27